Part 2, operations of functions, compositions. So the first one here gives us f of x equals negative 2x plus 5, and the first problem is asking me to find f of 3y. That means that my 3y is acting as my x, so I'm going to plug 3y into all of my x's. So I have negative 2. Instead of the x, I have 3y, and then I have the plus 5. To simplify, I'm going to multiply the negative 2 and 3y, so I have negative 6y, and then the plus 5. Negative 6y and 5 are not like terms, so I can't combine them, so this is my final answer. Here's the work for the second one. Make sure you distributed your negative 2 to both pieces inside of the parentheses. Okay, when we substituted 3y or 5a plus 1, all we really did was substitute one complete function into another function instead of substituting in a single number. This idea is called composition. So the composition of f and g, where f and g are both functions, is denoted by these two notations. I could write it as f, and then inside of my parentheses, I have my function g of x, or I could write it as f, and then a little open circle, g of x. Okay, these are both read f of g of x. If you decide to use this little open circle, notice that it is quite similar to multiplication. Take your time when you're looking at problems so you can tell the difference between multiplication problems and composition problems. Example 1 gives me a function for f and for g and asks me to find g of f of negative 3. So I'm going to start here with finding f of negative 3. F of negative 3 means that I'm plugging in negative 3 to all of the x's that I have in f. So instead of that x, I'll write negative 3, then I have a minus 5. Negative 3 minus 5 gives me negative 8. If I look back at my original problem, I then needed to take that and plug it into g. So from here, I'm finding g of negative 8. That means I'm taking negative 8 and plugging it into all of my x's in g. So I have negative 8 squared. Negative 8 squared is positive 64. So right now I have found that g of f of negative 3 is equal to 64. Just a tip, anytime that you are plugging in a number into a composition function, your final answer should be a number as well. You should not have any x's or variables left over. Here is the work for example 2. Please pause the video and check your work to find your mistake if you got this question wrong. Let's say that f of x is equal to 4x plus 9 and g of x is equal to negative 5x minus 2. In example 3, we want to find f of g of x. What we're doing here is taking g of x and plugging it into f. So I'm taking whatever's on the innermost part and plugging it in to the outside. So I'm going to start with looking at f. I have 4x plus 9. Instead of this x, I'm going to leave just a big set of parentheses. Inside of that parenthesis is where I'm going to plug in g. So in this case, negative 5x minus 2. From here, I'm going to simplify. So I need to distribute this 4 inside of my parentheses. So I have negative 20x minus 8 plus 9. Negative 8 and positive 9 are like terms, so they can combine to give me positive 1. This right here is my simplified final answer. Again, this time I was finding f of g of x, so it makes sense that my final answer should have variables left over. Okay, example 4 is going to go the opposite way. So now it's asking me to find g of f of x. So I'm going to be taking f of x and plugging it into g. So I'm going to look at my g function, negative 5x minus 2. Instead of the x, I'm going to write just a big set of parentheses. And inside those parentheses, I'm going to plug in the f function. So 4x plus 9. Again, I need to simplify, so I'll distribute my negative 5. So negative 20x minus 45 minus 2. Negative 45 minus 2 gives me negative 47. Notice that example 3 and example 4 give you slightly different answers, so it is important that you slow down, pay attention to which function is being plugged into where. Here are the answers for number 1 and 2. Again, pause the video and check your work. I would like to walk through number 3 with you because it is a little bit tricky. So number 3 is asking me for g of f of x. So I'm going to plug f of x into g. So I'm looking at g, I'm rewriting it, but instead of that x, I'm putting a big set of parentheses. Don't forget your little exponent. And in the parentheses, I'm plugging in f, so negative 7x plus 8. Now, with this little exponent here, a lot of students like to try and distribute the exponent. I cannot do that, though. What I need to do is take this binomial, the negative 7x plus 8, and write that twice. Anytime something is being squared, I'm multiplying it by itself. From here, I'm going to do a lot of distributing, and the order in which you distribute does not matter. I'm going to leave this 2 and distribute my binomials first. So negative 7x times negative 7x gives me 49x squared. Negative 7x times 8 gives me negative 56x. 8 times negative 7 is negative 56x. And positive 8 times positive 8 is 64. I notice I have some like terms here, so I'll combine those. Negative 56 minus 56 is negative 112x. And then I still need to take this 2 and distribute it inside of these parentheses. So 2 times 49x squared gives me 98x squared. 2 times negative 112x gives me negative 224x. And 2 times 64 gives me positive 128. If you're freaking out at this point, please don't. This is something that would be on the calculator part of the test. All right, let's take a look at number 4, a little bit easier here. We're going to start with finding f of negative 1. So I'm plugging negative 1 into all of my x's in f. So negative 7, negative 1 plus 8. Negative 7 times negative 1 gives me positive 7. And 7 plus 8 is 15. From here, I'm going to take 15 and plug it into g. So g of 15 is 2. Instead of the x, I'm plugging in 15. Again, this is something that you could definitely use your calculator for. Okay, 15 squared is 225. And 225 times 2 gives me 450. All right, in the next example, we are still going to work with composition functions, but this time we are going to be using a graph. So on this graph, they give me two functions. This little curve here is f of x, and the straight line is h of x. The first thing they're asking me to find is h of f of 5. Again, we're going to start with our innermost part, so I want to start with finding f of 5. Notice that the 5 is inside of the parentheses, meaning it is an x value. So I'm going to go on my x-axis to positive 5, and I'm looking for f. So I'm going to go up until I get to my f function. It looks like it is at a y value of 3. So I'm going to replace that circle here with 3. So it looks like I still have an h, but now I have a 3 in the parentheses. So the next thing I'll need to do is find h of 3. Again, I'm going to go on my x-axis over to 3. H is already crossing at that point, so the y value is 0. Alright, let's do another one. F of h of 0. Starting in the middle, I have h of 0. So x-axis, I'm starting at 0, looking for the h function, which is way up here at 6. Now I'm looking for f of 6. So on my x-axis, I go to 6. I'm looking for the f function, which is way up here at 6 again. The next one looks a little bit different. F of f, the process stays the same. So we'll start with finding f of 1. So on the x-axis, I go to 1. I'm looking for the f function, so down to negative 5. Now I'm searching for f of negative 5, so x-axis, I'm at negative 5, looking for f again, which is down at negative 2. Last one, h of 4, I'm finding h of 4 first, so x-axis at 4, down to get to h, which is at negative 2. And now I'm finding h of negative 2, so on my x-axis I start at negative 2. I'm looking for h, which is way up here at 10. Here are the answers. Please take a minute to check your work. Alright, this is the last type of question. It's very similar to the graphing ones that we just looked at, but this time the information is presented to us in a table. So the first one gives me h of g of negative 3. I want to start with finding g of negative 3. So it looks like this first table gives me f's and g's. I'm looking for where x is negative 3. So x is negative 3. It tells me that my y value is at negative 3 as well. Now I'm looking for h of negative 3, so I don't care about this first table anymore. I want to focus on this one that has h. I'm going to look for an x value of negative 3, and it tells me that my y value is at 2. The next one asks for g of h of negative 3. So again, I'm starting in the middle here, looking for h of negative 3. So x is negative 3, my y value is 2. So now I'm finding g of 2. First table gave me g. I need an x value of 2, and it gives me a y value of 7. And here are the answers to the last two problems.